We continue now with our series from Antarctica. The ice-covered continent is being transformed in part by climate change. Antarctica's ice, which contains the vast majority of fresh water on Earth, is melting at an accelerating rate. William Brangham and producers Mike Fritz and Emily Carpeau travel there and have this report on how coastal communities all over the world could be impacted. It's part of our occasional series of reports, Peril and Promise, the challenge of climate change.
For as far as the eye can see, Antarctica is covered by thick sheets of ice. In some places, that ice is several miles deep. This massive continent, as big as the U.S. and Mexico combined, has for millions of years been home to some of the most breathtaking examples of ice on the planet.
What you can see behind me here is a very good cross-section of a glacier in Antarctica. And what you can see with all of those different layers, that is hundreds and thousands of years of snowfall and precipitation stacking up one on top of the other and slowly exerting pressure downward on those layers of snow. And that's basically how a glacier is formed.
But Antarctica's ice is now increasingly being threatened, and most researchers believe it's because of climate change. According to one recent study, the continent's ice is slipping away 6 times faster than it was 40 years ago.
And Antarctica is now losing 252 gigatons of ice per year.
Glaciologist Joe McGregor is part of the team at NASA's Goddard Space Flight Center that's studying Antarctica's ice. Using radar and lasers, they measure the thickness of the ice, how it's moving, and whether it's growing or shrinking. This animation they built shows a sped-up version of how the ice flows on the continent.
Help me understand what that means, 250 gigatons.
A gigaton is a billion metric tons of ice. And when you do the math, you wind up with the Antarctic ice sheet is out of balance by more than 3.5 swimming pools per second.
Every second, 3 Olympic-sized swimming pools worth of ice is disappearing from Antarctica.
Yes, when considered on average over the year.
Just to put that in perspective, in the amount of time it takes to watch this story, Antarctica will shed more water than New York City uses every day. The warming that's causing this ice loss varies in different parts of Antarctica. Here on the peninsula, the long branch of land coming off the northwest corner of the continent, warming has been especially pronounced. At the Vernadsky Research Station, which is run by the Ukrainian government, meteorologists like Oleksandr Poluden have been keeping some of the longest-term temperature records on the continent. While it's warmed and cooled at different times, Poluden says the overall trend here on the peninsula is clear.
You will notice the temperature doesn't tend to increase all the time, as there are certain fluctuations from year to year. However, it becomes evident that over about 70 years, the average year-round temperature has increased by 3.5 degrees.
It's becoming clearer that parts of Antarctica appear to be unstable and are losing ice much faster than we expected.
Michael Oppenheimer is a climate scientist and professor of geoscience at Princeton University. He says this ice loss will only accelerate sea level rise, which happens for 2 reasons. One, a warming atmosphere warms the oceans, and warmer water expands and rises. Secondly, warming also melts ice and glaciers all over the world, sending new water into the ocean.
So ultimately, if we lose all the ice that's vulnerable to a warming of only a few degrees, we're talking about a very, very, very big sea level rise.
The most recent UN report predicts 1 foot of sea level rise this century if we continue burning oil and gas and coal at our current pace. But a growing number of researchers believe that because of the emissions we've already put up into the atmosphere, that prediction understates the threat.
The continent's warming from below and also, from above.
Alexandra Eisern oversees all Antarctic science for the National Science Foundation, who, for the record, is a NewsHour underwriter. She says that in West Antarctica, 2 huge glaciers, Pine Island and Thwaites, are considered at serious risk of collapse.
There's some researchers that study Pine Islands and the Thwaites Glacier that feel that it's become sufficiently destabilized that we won't be able to recover.
Michael Oppenheimer says if just one of those glaciers winds up in the ocean, sea levels will rise 5 times higher than the UN predicted.
The current estimates are if the Thwaites Glacier were to totally disintegrate into the ocean, that ultimately sea level would rise by something like 5 feet. In areas around some of our biggest cities, New York, Boston, Miami, where you've got a lot of development, homes, buildings, infrastructure like roads, very close to sea level. How do you defend those? How would Bangladesh protect itself? It's got many hundreds of miles of coastline. It's all right at sea level. You can't build a wall to protect that whole coast. There's actually nothing that can be done.
That's millions of people that are going to have to move.
Right. There are about 150 million people that live in Bangladesh, and probably a few million of them would have to move back. And where are they going to go in such a densely populated country? And there's already strife when people try to move into India. People get killed trying to do that now. What's going to happen when you have a few million people that all of a sudden try to move? It's not a pretty picture.
Part of the reason Antarctica's glaciers are threatened is that they've been losing some crucial protection. Many glaciers form what are known as ice shelves, huge platforms of ice, some as wide as Texas and hundreds of stories tall, that grow out over the ocean and help hold their much larger glaciers up on land. They hold it back and not let it slide into the sea.
Imagine a piece of ice the size of Texas, pretty thick, is going to slow the ice as it tries to flow into the ocean.
Robin Bell of Columbia University's Lamont Doherty Earth Observatory has been studying Antarctica's ice for over 20 years.
Ice shelves are very important. They're essentially acting as bouncers in the bar, leaning up against the door and keeping the ice from flowing into the ocean.
But as the atmosphere keeps warming, major ice shelves in Antarctica have also been collapsing. In 2002, the Larsen B ice shelf, the size of Rhode Island, completely disintegrated. These are satellite images of it breaking up into hundreds of pieces. As predicted, the glaciers that Larsen B anchored up on land began accelerating towards the ocean. And then, 2 years ago, the even bigger Larsen C shelf, this is it from the air, developed that miles-long crack in it. This shelf, which sits in front of the Thwaites Glacier, is also crumbling. And part of the Brunt ice shelf is expected to break off any day now, releasing an iceberg that'll be twice the size of Manhattan. There's still some debate over whether human-induced warming is the only thing causing these changes. Antarctica has lost ice many times before, and that also caused the seas to rise. Researchers are now trying to determine how much warmth it takes to cause truly catastrophic sea level rise.
That massive glacier that you see behind me connects all the way up above those peaks to the enormous West Antarctic ice sheet. And all of that ice and snow contains a remarkable history of Earth's past climate.
It's like a tape recorder, 10,000-foot tape recorder in places. And so scientists have drilled ice cores through the layers as far down as they can get, and then they analyze those layers.
Glaciologist Robert Mulvaney, that's him in the black cap, works for the British Antarctic Survey. He and a small team have been drilling over 2,000 feet down into the ice sheet and pulling out these ice cores.
What we've been trying to do is recover a climate record of the last glacial cycle, so the last 120 to 140,000 years, to try to understand how our climate might change over the next 100 years or so as the climate responds to increased carbon dioxide in the atmosphere.
The evidence from these cores and many others indicate that when the Earth's climate was just a little bit warmer than it is today, the world's oceans were over 20 feet higher.
So 120,000 years ago, when the climate was probably 2 degrees warmer than today, and sea level was maybe 6 to 9 meters higher than today.
Given the uncertainties over how serious sea level rise will be and over what time span it'll occur, Michael Oppenheimer argues that there's still time to act and to prepare.
Doesn't mean we should all throw up our hands and run. Let's start thinking straight. Let's start thinking fast about how we're going to help people, how we're going to help settlements, how we're going to help countries deal with the outcome. Because a lot of it is not going to be pretty, it's going to be expensive, and it's going to be disruptive if we don't get our act together now.
This year, teams from several different nations are studying the Thwaites Glacier, trying to determine whether it's past the point of no return, and if so, how soon its ice could end up in the ocean. For the PBS NewsHour, I'm William Brangham in Antarctica.